All right, welcome back, Algebra 1. We are going to go through notes number 3. Hopefully yesterday or today at some point, or whenever you're watching this video, you've worked through quick check number 1. So if you're on this set or on this video or on notes number 3, I would stop here and make sure you've got homework 1, homework 2, and the quick check number 1 all the way done. Once you've got those 3 things done, then you are ready to work on notes number 3. One quick little reminder, remember, and I put this on the quick check, this PDF right here, this is where you can click if you want a blank copy of anything that we're doing, so you can print it out. It works a lot better if you click on that PDF than if you just print from this page you're looking at in OneNote right now. That way you only get the notes and you don't get all of the stuff I wrote and the extra pieces on the page. Okay, so we've now gone through graphing systems of equations and solving a system of equations by graphing. We saw how we can graph 2 lines, find the point where they intersect, and that's your solution. Or sometimes the lines are parallel and there's no solution. Sometimes the lines are the same and there's infinite solutions. And we also did systems of inequalities where we had to shade where the 2 shadings overlap, and that's where your solutions are. Okay, now we're going to start looking at the algebraic way to solve systems of equations. And we're going to start with our first method, which is called substitution. We're going to look at 2 different methods to solve systems of equations. You will be required, kind of in Algebra 1, to do both of these methods. As you go on in math, you can usually pick which method you like better. In Algebra 2, we do both methods. You can choose which one you like better. But for right now, we want to make sure you understand both so you get a good grasp of that. Okay, so first method, substitution, right? Kind of what it says. It's called what it means. We're going to substitute one equation into the other to figure out what one variable equals. Okay, so we're going to take this system that we've got here. So x, oops, I get the right pen on there. So we've got the x plus y equals 15 and 4x plus 3y equals 38. Those are our 2 equations. We don't want to graph them this time. Instead, we're going to solve it algebraically. So we're going to walk through the steps and then we'll try a few others just to go through it a little quicker. Okay, so step number 1, we want to take one of the equations and solve for one variable. Now this talks about making a smart choice. The reason I say that is you can make a choice where hopefully you don't end up with a bunch of fractions. So any equation works and you can solve for any variable. But what I mean by make a smart choice is if I take the second equation, so if I take that 4x plus 3y equals 38, and I solve that for, let's say I want to solve it for y. So I move over the 4x, right? I would subtract 4x over here, and then I'm going to have to divide everything by 3. Well, 38 is not divisible by 3, and 4 is also not divisible by 3. So we're going to end up with fractions there, which will make your work just a little bit more complicated. So if you don't want to end up with fractions, a smart choice means you want to pick the equation where there's a 1 in front of a variable. So in this case, I'm going to pick that x plus y equals 15. Right? So I'm going to take that equation, and then I want to solve for one of the variables. It does not matter which variable you solve for. I tend to find that everybody always wants to solve for y because that's what you're used to when we talk about linear equations, but it doesn't matter which one you solve for. We'll do kind of one of each today. Okay, so let's say we're going to solve for y. So that means I'm going to subtract x on both sides. And then we end up with y equals, and you can write this as 15 minus x, or if you want to do negative x plus 15, that's fine. But there I've accomplished my first step, right? I took one of the equations, I solved for one variable. Okay, step number 2, we're going to substitute this expression for the variable you solve for into the other equation and then solve for the variable that's left over. Okay, so basically now I'm going to take the other equation. I'm going to take this 4x. Actually, let's write this first. So in the first step, we found that y equals 15 minus x, right? So now I'm going to take my other equation, my 4x plus 3y equals 38. And what this first equation says, this says that y equals 15 minus x, right? So I'm going to take that 15 minus x and I'm going to substitute it in for y because that's what y equals, right? So I'm going to do 4x plus 3, but then instead of y, I'm going to plug in what I said y is equal to, which is 15 minus x. And then I still do equals 38, right? So all I did was I took the second equation and I replaced or substituted the 15 minus x in for the y. Okay, then we can solve because now all I have left in this equation are x's. So I only have one variable left. I can solve that. So that would be 4x, and I'm going to distribute in my 3. So plus 45 minus 3x equals 38. Okay, then I've got 4x minus 3x. That's just x plus 45 equals 38. And then we're going to subtract our 45. So then our x would equal 38, minus 45, which is, what's that, 7, right? Negative 7. Negative 7. Okay, so now I've got x equals, right? I've got 1/2 of my solution. I have the x value. So now, in order to get the solution to a system, remember the solution to a system of equations is an ordered pair. I've got the x value, now I need the y value. So now I'm going to take that x equals value and I'm going to plug it back into the first equation that we did. So again, that first step we did was we said that y equals 15 minus x. Oops, if I can write 15 minus x. And we just did all this work over here where we said that x equals negative 7. So I'm going to take that result and I'm going to plug it in for the x. So now we get y equals 15 minus, and I'm going to plug in negative 7 for the x. Watch your signs. That's where a lot of mistakes can happen. That would mean y equals 15 plus 7, and 15 plus 7 is 22. So we get y equals 22, right? That means the solution to our system as an ordered pair would be negative 7, 22, right? Our x value was negative 7, our y value is 22. Okay, and then last but not least, we can check our answer. You don't have to check your answer. I'm just saying that you can, like if you're on a test or a quiz in the future and you want to make sure that you got the right answer, we want to make sure, remember, like we did in the very first set of notes in this unit, you want to be able to make sure that that solution works for both of those equations. So I'm going to look back at my original equations that I had. We had x plus y equals 15, and then 4x plus 3y equals 38. So I'm just going to take my solution, plug it into each of those, and make sure that they work. So our first one, I would do x, our x is negative 7, right? Plus our y is 22, should equal 15. Negative 7 plus 22 is 15. So 15 equals 15, it works. And then for our second equation, I'm going to do 4 times our x, which is negative 7, plus 3 times our y, which is 22, should equal 38. That would be negative 28 plus 66, and that should equal 38. Excuse me. And then negative 28 plus 6 is 38. So 38 equals 38. We've got a winner. So that means our solution is negative 722. Okay. This method can be a little bit complicated sometimes. A lot of people have a lot of trouble with this step number 2. So just remember, you're just taking that and plugging it into the other equation. All right, let's try a few more together so we can kind of see a few other things that happen and just remember how this works. Okay, so this one, we've got our system of equations, right? So again, you can pick any equation and solve for any variable, but it's nice if you make a smart choice. The smart choice here, I see it, it's this x right there, right? There's a 1 in front of it, which means I won't have to deal with any fractions when I solve it for that variable. So I'm going to start with that. So our first step is I'm going to take this x plus 4y equals -9. And I'm going to solve for that x. So I'm going to subtract the 4y over to this other side. And then we get x equals -9 minus 4y. Or if you write -4y minus 9, that's fine too. It doesn't matter, right? Okay, so there's step one. Step two. Now I'm going to take that, right? This is what x is equal to. So I'm going to take my other equation, which is 2x minus 3y equals 4. And I'm going to take what x equals and I'm going to plug it in for that x in the other equation. So that means I would get 2, but then instead of x, I'm going to fill in -9 minus 4y. And then minus 3y equals 4. Okay, and then see how it's got all y's in that equation? If you end up on step 2 right here, if you have both an x and a y still, you've made a mistake with your substitution. After this step where you plug that in, you should only have one variable left because then you can solve for that variable. Okay, so now I'm going to distribute in that 2. So 2 times -9 gives us -18. And 2 times -4 would be -8y. And then minus 3y equals 4. I've got some like terms I can combine here, right? So then we get -18. -8 and -3 would make -11y equals 4. I'm going to add the 18 to the other side. And we get -11y. 4 plus 18 is 22. Divide by -11. And we get y equals -2. All right, there's the first part of our answer, right? We've got one part of our ordered pair. There's the y value, but now we need the x value. So our last step is to take, again, that very first equation we had, x equals -9 minus 4y, and then we're going to take that y value and plug it in, right? I won't be able to draw over that. Draw it this way. So plug it in there, right? Okay, so x equals -9 minus 4, and now we can plug in -2 for y. So -9, -4 times -2 would make +8, and then -9 plus 8 gives us -1. So there's the other half of our answer. So that means the solution to this system is the ordered pair -1, -2. Make sure you get your ordered pair in the right order. It should always be x comma y, right? There's the solution to our system. And remember, that's the point where if I went back to these two lines and I graphed them, this is the point where those two lines would intersect and where they would cross. Okay. All right, so there's another example there. All right, let's try another one. Now, this one's kind of nice. We've already got a y equals and another y equals, right? Those are both already solved for y. So that first step is already kind of done for us. You just need to pick one of the equations, and it doesn't matter which one. I'm going to pick the first one. So our first step was solve one equation for one variable. It's already done. So I'm going to use y equals 3x plus 1, right? That's done. Okay, step number 2 is now I'm going to take the other equation, which is y equals 3x minus 7. And we're going to substitute in what y equals, right? So we've got this 3x plus 1. I'm going to plug that in for the y because this says y equals. Okay, so then instead of that first y, I'm going to plug in 3x plus 1 equals the rest of this equation, 3x minus 7. Right? I just replaced the y. Okay, we don't really need those parentheses this time because there's no distributing to do, right? So 3x plus 1 equals 3x minus 7. If I get the 3 x's together, you kind of see that something weird is going to happen on this one. That's a 0 and that's a 0. So all we're left with is 1 equals -7. The x's are gone, right? This has happened to us before when we're solving equations. If that says 1 equals 7, it is definitely not true. 1 does not equal 7, right? So we end up with a statement that is not true. If that's the case, then that means there is no solution to this system. Okay, so if you get rid of the variable, but you end up with a false statement, that means there's no solution. And look back at your lines. Look at these slopes. We had a 3x and a 3x. If two lines have the same slope, remember that means that those lines are parallel, right? And if two lines are parallel, can they ever cross? No. So if they can't ever cross, then they don't have a solution because we can't find that intersecting point. All right, let's try one more here. So we've got two equations again, right? Our first step is we want to pick one equation to solve for one variable. Doesn't matter which one. I'm going to bet that a lot of you are going to look at this one and say, ooh, a fraction, I don't like it. So if you want to start with that one, we can get rid of that fraction. And that's what I'm going to do. So I'm going to do this y over 2 equals 2 minus x. Let's get rid of that fraction. So to get rid of it, I can multiply everything by 2, right? So then 2 times y over 2, that's just y. 2 times 2, right? We're distributing this in, is 4. And 2 times x is negative 2x. And then, hey, look, we've got one of our equations solved for one variable, and we got rid of that fraction that now we don't have to deal with. Okay, step number 1 is done. Step 2, we take our other equation, 6x plus 3y equals 12. And we're going to take this guy we just solved for, and it says y equals, so I'm going to plug this in for the other y, right? So we keep our 6x, we keep the plus 3, but instead of y, we're going to plug in 4 minus 2x, and then equals 12. All right, so then to solve, we got to distribute in that 3. So 6x plus 3 times 4, that's 12. And then 3 times negative 2x would be negative 6x equals 12. Our like terms here, 6x minus 6x, that's 0x, right? So the x's are gone. We end up with 12 equals 12. Okay, so this time we got rid of our variables. They canceled out. But this time, does 12 equal 12? Yes, it does. So we end up with a true statement, right? If we end up with a true statement, then that means we have infinite solutions. Okay, infinite solutions because really these two lines are actually the exact same line. If we were to put them both in slope-intercept form, you would see that they're actually the exact same line. Now, remember on the notes the other day, we also talked about how to actually write the actual solution to this. So we can write that in set notation. We said that the answer is actually the set of all the ordered pairs, x, y. We make a vertical bar, and that means such that, and then I write one of the equations. It doesn't matter which one. I like to do the one that says y equals, so I'm going to use that one. So y equals 4 minus 2x. But you could do the y over 2 equals 2 minus x. You could put the 6x plus 3 equals 12. It does not matter which equation you write there, just as long as you write the equation. So the answer to this one would be an infinite amount of solutions because it's all the ordered pairs that satisfy that line, that y equals 4 minus, or that are on that line, y equals 4 minus 2x. Okay. All right, so there is solving systems by substitution. This one's a little bit tougher, but try your best to kind of go through each step. If you've got questions, let me know what they are. In our live class time tomorrow, we can go over a few if we need to, or I guess I should say today, whatever day it is that you're watching this, but just hit me up in Google Chat if you need, or in Google Chat if you need any help. Best of luck to you. Oh, and your homework today is still on Delta Math. So you'll go back there and work through those again. Make sure you're writing down your work and doing it on a separate sheet of paper. Don't just go through and guess on the problems. You're still going to be responsible for this stuff on the final. So I want you to make sure you're attempting to learn as much as you can through all these video lessons. That's the point of e-learning, right? But take breaks, get some rest too, okay?